And now for an even more evil integral, the integral of secant cubed. Oh, if only it was secant to an even power. You could leave 2 secants alone, turn all the rest of them into 1 plus tangent squareds, 2 at a time, and then you would have a whole bunch of tangents with a secant squared left over. U equal to tangent would totally save the day. No, no, no. The trick here is to look at this as the integral of secant of x times secant squared of x dx, and use integration by parts. U is the secant of x. The last thing we'd ever want to set u equal to is a trigonometric function, but dv is secant squared of x dx. We do know how to take the derivative of secant. It is secant of x tangent of x dx, and we do know whose derivative is secant squared. It's just tangent of x. So this whole thing turns into uv, which is secant x tangent x, minus the integral of v du, which is the integral of secant of x tangent squared of x dx. What do we do next? What we do next is we copy this whole thing over again, except that we turn this tangent squared, and let's see, tangent squared plus 1 is secant squared, so tangent squared is secant squared of x minus 1, and we multiply that out, and we get, let's move this over a little bit, equals secant of x tangent of x minus the integral of secant cubed of x dx minus plus the integral of just secant of x alone. And this whole thing, if you remember, what we're trying to solve is the integral of secant cubed of x dx. We can move this one to the other side and get 2 integral of secant cubed of x dx equals secant of x tangent of x plus, hey, the integral of secant of x. I'm sure you know that that's the natural log of the absolute value of secant of x plus tangent of x plus c. And if you divide both sides by 2, you will get that the secant cubed of x's integral is 1/2 secant x tangent x plus 1/2 natural log absolute value of secant of x plus tangent of x plus c. And the very similar trick will tell you how to work with the integral of secant to the 5th x dx, except that you're going to get down to the point where you're going to have to just have this whole thing memorized. And integral of secant to the 7th of x dx is going to be use u substitution, and you'll have to know what that is off the top of your head. Basically, secants to odd powers are awful to work with. If they're even, it's so much easier, but they are doable.